Life is a flash of lightning in the dark of the night. It is a brief time of tremendous potential. A very good morning and welcome you all to the Lightning Protection Design Workshop organized by the IEEE Student Branch of University of Ruhuna with Power Circle of EIES. Undoubtedly, this morning will be a great opportunity for you all to reveal more things about lightning protection design. And this workshop also intends to highlight the importance of lightning protection systems as they are used to prevent or lessen lightning strike damage to buildings. So to take a nice onset to the session, I'm honored to invite the first chairperson of the Women in Engineering Affinity Group, IEEE Student Branch of University of Ruhuna, lecturer Ms. Dinuwanti Valimilla, to welcome the gathering. Over to you, madam.
Okay, thank you very much, Navodya. Good morning to all. And I here warmly welcome Engineer Laksith Siirisena, consultant at Amithi Power Consultant Private Limited. And he is the person who is expert in electrical installation designs, and happy to say that he was the person who guided me, taught me on lightning protection designing. And Engineer Laksith Siirisena, thank you very much for accepting kind request to conduct the workshop today. And also I can see among participants there are undergraduates as well and graduates as well. So again, thank you very much, Engineer Laksith Siirisena, and also participants. Let's move to the workshop. Thank you.
Thank you very much, madam. Before moving to the session, I would like to invite all of you to switch on your camera to take a snapshot. Thank you, everyone. So without any further delay, let me introduce the guest speaker of today's workshop. He graduated a Bachelor of Science in Electrical Engineering in University of Moradua in 2014 and Master of Science in Electrical Installations from University of Moradua in 2018. And he is a Certified Chartered Engineer of Institution of Engineers Sri Lanka. He is currently working as an electrical consultant at Amithi Power Consultant Private Limited. So I'm extremely honored to welcome Engineer Laksith Siirisena. Warmly welcome and over to you, sir.
All right, hope I'm audible to you.
Yes, sir, you are.
Okay, great. Wishing you all a very good morning. And first of all, I should thank University of Ruhuna IEEE chapter for inviting me over to conduct this workshop, especially Dinuwanti for inviting me to share my knowledge on this subject of lightning protection systems and to add or modify what you have mentioned earlier in this workshop that that I'm the expert in electrical installation design. So in the industry, there's no particular expert as the best expert, but there are plenty of experts in the industry. Like still my superiors and my teachers, the lecturers, they are the best experts in the industry. I'm just privileged to be a person who grabbed the knowledge and had the opportunity to practice in the industry. So when it comes to lightning protection systems, you know, there are experts in Sri Lanka itself. There are plenty of professors, doctors from universities, and as well as my superiors like uh, Professor Gomez, Professor Lucas, and Dr. Asanka, Mr. Ryan Fernando, and Mr. Kaushalya from my organization itself. So I consider them as the experts from my perspective, but for students, I believe I can transfer some sort of knowledge and my experience during the past 8 years in this consultancy field. So with that correction, I would like to continue this session. So I believe this is a workshop and not a lecture, right? So this should be an interactive session. I believe there are 39 participants, like the student count shall be around 35, I believe. So this should be an interactive session, not a lecture. So with a lecture, I would be presenting something from start to end. But when it comes to a workshop, it's a more practical session. So that's what I'm oriented for. And I'm not going to conduct a lecture today. I hope, Dinwanti, I'm correct. Like, this is the purpose of this workshop, is to grab certain hands-on experience during the session itself.
Yeah, exactly. Yeah.
All right. Okay. So since the students who are participating and who are expected to participate will be evaluated from the knowledge gained from this workshop, I expect their participation in this live session as well. So to start off with the lighting protection systems, I would like to share a previous presentation of mine to overview what you already learned about lighting protection systems and what are the considerations when it comes to designing of those LPS. LPS stands for lightning protection systems. All right, let me share the screen. Can you see the screen yet? No?
Not yet, sir.
Let me. The PowerPoint application is not displayed. I'll share the entire screen. Right. Hope you can see.
Yes.
Yeah, okay. And still you can see, right?
Yes,
Please
sir.
give me heads up. Okay. Okay. So this is a lecture I conducted at University of Moratuwa. I believe some of you might have already seen this, but we shall revisit the basic concepts of lighting protection systems first to make it an effective session today. So the previous lecture topic was industrial aspects of lighting protection systems, but this is oriented towards grabbing the basic understanding of LPS. So we'll go through what are the basic concepts first. So I'm allocating the first session about revisiting the knowledge of lightning protection systems, especially focusing on the design aspects. So Dinwanti, I believe that approach will be better with the target audience, right?
Sorry.
I believe this approach will be effective for this targeted audience with the university students.
Yeah, because there are some of graduates as well. Other than,
okay. Right. So I believe to make it more effective, then we shall focus more on the basic concepts first. Although you might have already learned it, this revisiting of concepts is really, really important because it's an updating field. Lighting production systems is an updating field. Therefore, although certain parts had been already included in this presentation, so there are some added knowledge which is beyond what's mentioned in the slide as well. So I'll go through the presentation first. So as you can see, the first image shows you a building with a lightning arrestor, which is mounted at the right corner. Whereas you can also see a part which is damaged by a lightning strike. So this particular damage is reported to be a lightning origined. So this is from a research paper published in 2008. So therefore, the reliability of information is expected to be true. So we'll see what happened over here. So you can see you have already a lightning arrestor mounted in the building, yet there had been a damage right after, I mean, sometime after installing of the lightning protection systems. So why would this happen? So this is not quite expected by a facility owner. So I installed the lightning protection system, but why do I get lightning strikes again? So this is not quite expected by the person who invested in lightning protection systems. So this is why we need proper designing. Having a mere lightning protection system or air terminal in the building is not adequate to protect a building against lightning strikes. So as you were given introduction at the session, the expectation of lightning protection systems is to mitigate the risk. So you cannot totally eliminate the entire risk, but there will be a residual risk. However, you can eliminate the majority of risk to your building. So that's how it's based. So for instance, the standard IEEE is not guaranteeing you a total protection against anything. So I mentioned the standard IEEE, and I hope you can see what I wrote. Can somebody respond, please? You can see what I wrote on the screen.
Yes, sir.
Okay, great. So this standard is mentioned in the presentation, but in the meantime, get familiarized with more terms because you'll be doing your designs based on IEC. So I'll be going through the IEC standard as well, where to extract, and while we are doing an example, so we'll go through because this is not this learning process with the designs is not a straightforward one. It's not a simple line. It's like associated knowledge. Like it's like this. All right. So over here you have in the peripheral, you get standards, you have research papers, you get forums, and also you get product specifications. So likewise, this design process is not a straight line. You have to have some look around in the industry and the academia as well. So I believe you get some introductory knowledge about this design process as well. So we'll move forward. So I will not go through the same lecture outline because this is not a lecture. I'll just go through the content to give you some basic understanding about lighting protection systems. So to start off with, we have to know what is lightning. In vocabulary with the dictionary meanings are given for lightning as it's an electrical discharge caused by imbalances between storm clouds and the ground or within the cloud themselves. So this is from the Cambridge dictionary. So it's an electrical discharge. So okay, so although you get lexical as Oxford is published, it also mentioned about an electrical discharge. So it's a common clause, and you already learned this in your physics lessons, I believe. And further, it is caused by an imbalance between storm clouds and the ground. So it's a natural phenomena, you can understand. So it's happening in between the storm clouds and the ground. It's a discharge process. So you got clouds and you get the ground and there's a discharge. So in between this it's like a transient process. In between there are multiple stages which is covered under lightning physics. Lightning physics is a separate area. Lightning physics. So it's an expertise area, right? Engineers who are interested in lightning protection may further study in this lightning physics as well. In Sri Lanka, there are experts in lightning physics to mention like Professor Gomez. So you all can refer his research papers and his studies and his lectures as well. All right. So I'm sharing all this knowledge for you to develop further beyond what is being practiced in the industry nowadays. So because you are the future and we want you to learn beyond what we are practicing with the updating standards and with the updating knowledge. We are always updating with the industry practices, but lightning physics and the academia proportion to the industry is really important as well, because that's where the industry is evolving. All right, the lightning process is simply derived in these 4 processes, although it is a multiple stage process. So you can see initially the thunderstorm is developed with the charge separation. You can see the positive charges over here and the negative charges over here. So this charge separation is due to various processes happening inside the cloud. There are turbulent wind motions inside the cloud with the different types of particles, and there are dust, ice, and other particles inside the cloud. So they have inherent characteristics according to their properties. So while in motion, they separate, and they tend to separate at their own polarities initially. So once it's been separated, this charge separation is that process. And you can see there's a leader. There's a leader forming downwards, and the step trees, the cloud's bottom induces earth structure. So that's what's happened over here. You can see with the negative charges beneath the cloud, you have positive charges induced on the ground. And that's what happened. And there's a step leader from cloud to ground. So while it's been charged, there's a tendency towards that further extending towards that its electric field. So with the increasing voltage, the static voltage in the cloud, so the intensity of its electric field also increasing. So it increases and it gradually reaches the ground as a step leader. And while being the ground induced in the opposite charge, it also sort of emits and further elongates a streamer from the ground to the sky. So we call this the streamer. And this is the leader. And when these two meets at a certain point, and the ionized path will establish, and the discharge of charges from the cloud to the ground at a higher current in kiloamperes range will occur within few microseconds. And there could be multiple instances of the same striking. So when you can see while thundering, there are multiple strikes happening at the same spot. So because the air volume around this ionized path is already been ionized. So there's a higher probability for restriking of lightning at the same location within this short period of time. So that's the basic process of lightning. Without further delay in these basic principles, I will move forward. So you can further research on what's this lightning process, and you can see starting from this initializing time t0 in milliseconds, you get this process developing, right? The process I mentioned, this attachment process, and the first return stroke is coming from Earth. And after this path is established, you can see there are subsequent return strokes as well. So these are the snapshots of a lightning process. So these waveforms are quite important for us. So these are lightning waveforms. And these current waveforms are really, really important for us to protect our appliances, because when you talk about lightning protection systems, you get external lightning protection systems and internal lightning protection systems. So what you saw earlier, what is mounted on buildings is an external lightning protection system. But apart from that, you still can get affected by the lightning to our internal system. So there are why you need internal lightning protection systems. So when it comes to internal lightning protection systems, these waveforms will really matter, because these waveforms are traveled along our service lines. Service lines as in could be our power lines, communication lines, or even through our metal pipelines. In Sri Lanka, we do not have metal pipelines distributing services to residences, but when it comes to a large premise like an industry, there are lots of metal pipes involved and traveling all around the premise. So it's a carrier of lightning currents. Therefore, having internal lightning protection systems and proper earthing and bonding, these are keywords: earthing and bonding. Apart from these, LPS is really important. So it's a collective knowledge and collective process as well. So when you discuss about light and protection systems, you cannot forget earthing and bonding. And when you talk about light and protection systems, you cannot eliminate other processes such as these. Even when it comes to high voltage systems, you know about the reflection of surges, right, with the mismatch of impedances. So likewise, there are lots of other high voltage concerns, high voltage applications. You have those concerns as well, because we are installing lightning protection systems not only to our low voltage or not only to our structures, but when you design medium voltage or let's say high voltage systems, medium voltage or high voltage systems, which is beyond 1000 volts, there are surge arresters as well to protect the transformers and the rest of the equipment or components in substation or even distribution station likewise. So these surge arresters, lightning protection systems, those applications are limitless. Therefore, the associated knowledge with these lightning protection systems is really important as well. You cannot keep them alone. Well, we'll move forward. So lightning peak currents are illustrated here. So you can see at how the positive first strokes and negative first strokes, those positive and negative first strokes mean the direction from the cloud to the ground according to the polarity in between the charge separation. Either the first positive strokes could be ground to cloud, or the vice versa with negative strokes. And if it's a negative subsequent stroke, which is subsequent means which is coming after the second, third strokes. So you can see the negative first stroke is in the amplitude of this range, and the second one you can see in this range. These are the currents, right? Peak currents. So you can see. So this is in logarithmic scale. So from 2Ka to 20, 30, like 40K range, you have the subsequent, whereas the first strokes with higher current. So you can see with the subsequent strokes, the amount of current is lessened. So it's a natural process, and you have to apply certain amount of physics and as well as some research derived from these data. So why we are discussing about this lightning protection system. So the damages caused to different stakeholders in this community and in this world matters to us. So the stakeholders in our community would be occupants or structures or the contents inside the particular structure. So occupants, occupants are the people, simply. So structures are the, what are structures where the occupants or a particular process is occurring. Let's say a residence, a factory, a hospital, or maybe a warehouse storing explosives. So when it comes to like a warehouse having explosives, its contents is really important as well. So what you have inside the structure also matters to us. So what you have inside. So these contents is important for us. So why? Because the occupants could either be humans or animals. So in the standard we say like, so we call them livestock. So both humans and animals matter to us. And when it comes to structures, they are constructed with wood, brick, concrete, reinforced concrete, steel frame construction. I believe the university students have some understanding about these terms by the time. Reinforced concrete, steel frame construction, these terms come in the construction industry, although as engineers, you are expected to know these terms because these also comes in this study of lightning protection systems as well, because these materials matter to us. The materials used for constructing the structures will decide what sort of protective measures we shall practice. So the contents inside a structure could be combustible or either non-combustible, or could be explosive or vice versa, and electronic systems. So as electrical engineers who are the majority audience here today, so this will matter to you. Electrical and electronic systems with low or high withstand voltages. So these withstand voltages, this immunity of electrical appliances or equipment against the surges will decide the lifetime of a particular equipment, which is experiencing continuous effects of lightning. So this is what happens to you in exclusively during these months of March and April. So we get lots of inquiries and reports about these damages to appliances and industry equipment, say like even VFDs. VFDs are worth millions in industry, and having a VFD gone is a loss of millions of investments and the downtime. Because why we do all these is to protect humans, animals, and as well as to protect our assets. So these are actually our assets. Assets are our what come. Okay. So occupants is the priority. The value of lives is not definable. They are invaluable. Therefore, occupants come first and the assets come second. But in Sri Lanka, you know, with our mentality, certain industries and certain businesses focuses more on assets rather than occupants. So it's a really, really bad practice in Sri Lanka. And with our, I don't know, like what are genetically written codes in our blood. So people are concerned more about money and the wealth more than the life of occupants. So this is not, I'm not talking about the general public, but more about this business community. So it's really bad, but as engineers, that's our responsibility to deliver this message and to take corrective actions whenever these incidents happen, because we've seen lots of these unfortunate incidents happening. So once audit is conducted, the outcomes will be really unfortunate for the business owner if they had not taken the proper measures proactively and predominantly. So these proactive actions by the owners is really important. So what sort of damages to occupants could happen? So you can see these are sensitive images. I shall warn you if somebody is sensitive, these images better not to look at. I'm sorry not for being able to warn you before the slide. So these sort of damages to occupants could occur as a result of lightning strikes. So you can see that the requirement of proper lightning protection systems. So these considerations will be taken during our lightning protection system design as well. So that's why I'm showing you this. When you conduct risk calculations, when you conduct risk calculations, so these matters will be taken into account. The damages to occupants. These terms are not just put to conduct some of any knowledge, but to deliver the keywords and the key components or designs. So you can see the damages to people and as well as to livestock. The cattle sheltered under tree got struck during a lightning event. So when a lightning current follows along the trunk, there's a voltage rise, the potential rise along the profile of the ground. So when a cattle, let's say this is a cattle, is a bad cattle I wrote. Okay, so you have a voltage difference applying between the legs of the cattle. So this is what happens when you stand near a tree with your legs apart. So better keep your legs close to each other during lightning events if you are outside. All right. So these are common incidents, rarely in Sri Lanka, but quite common during the lightning peak seasons like March, April. But when it comes to international news, you can see lots of these events as well. So the damages to structures. So damages to structures. So you can see how the entire pile of roof tiles had been destructed along with these structural elements in the house. So I also seen plenty of these events at residencies and at factories. So this is real. This is happening in Sri Lanka as well. So keep that in mind. And you can see from in Australia, in Sydney, the firefighters had to keep down a fire in a warehouse. So these incidents do occur. And the contents. So I mentioned you about the electrical and electronic components. You can see how the electronic components are damaged. So you might even have experienced this with especially your Wi-Fi router, and also I have even experienced similar scenario, but I was able to repair it by simply replacing certain capacitors and resistors because the damage was less. But here you can see an entire portion of the circuit board is gone. Your PCB parts have broken. The capacitors are gone. You have to evaluate the damage. If it's any expensive equipment, it's beyond repair most of the times. And you can see an oil terminal, an oil storage tank. Explosion happened in Mumbai. Fortunately, no casualties happen, but you can see the structure is gone forever. You cannot repair this with such a heat accumulation, and the deformation happening in the steel structure is irreversible. You cannot take this back into service. You have to completely demolish this and construct a new storage tank. It will cost millions because you have to establish all these services, the steel structures, all the commissioning works, all the professional works required. So it's a big amount of investments you're talking about. So I believe the damages to lightning, the damages caused by lightning is clear to you. If you have any further questions, we may discuss now about the damages. So I'll give a few seconds if you have any question or any discussion you mean, because this is a workshop. I'm not going to conduct a lecture after my first session. So everyone has to participate and have to contribute. So Dinwanti, if you are going to evaluate students, I think this is a good opportunity for you to evaluate as well.
Yeah, okay. I think Pasan Minesh have you raised hand?
Yes, I'm in there.
Okay,
Hello,
you
hi.
can.
Hello.
Hello, yeah, I can hear you.
Actually, I couldn't hear the question.
You raised hand. You're going to ask a question.
No, actually, I don't have any questions.
Okay. Mistaken.
Okay. Okay, Dinwanti, in the university premise itself, have you experienced any lightning oriented issues? Any reports during your stay at the university?
I was at the university for about 4 years, but still I haven't faced any kind of
Problem. Yeah, so right. Okay, so I asked that question because you can see even during the past 4 years, let's say like it could be like 5 years now, 5 years, there had been zero
Yeah.
event. Yeah, there had been zero events under the observation of a particular person, excluding the instances where a particular person is absent. So during the stay, like let's say you are staying at the university for 8 hours a day, and let's say you're coming 20 days per month, and excluding the vacations, and let's say effectively you are coming for 10 months a year and 5 years. So you can see number of hours during the entire period. So I believe it's like 8,000, 200 into 5,000, yeah, 8,000 hours. During the past 8,000 hours, there had been no incidents. But the problem with lightning is it's coming quite randomly. It could be even once in 10 years, once in 20 years, or in certain areas, it could be sometimes 5 times a year, or even 15 times a year, right? So it depends. It depends on the geographic location of your premise. So I will show you a map where you can see the probabilities of the lightning events happening in Sri Lanka, published by the meteorology department, as well as I found from a few research papers. So you can see the probability really matters, and these probabilities are taken account to determine the risks which we are going to face. These key terms, please keep them in mind. So for your knowledge and as for your assignments, I believe they will really matter to understand and to design. So when determining these risks, the number of events occurring will matter. So we'll come into this part later on during the design part. So why lightning matters? For this will matter to residential buildings, commercial buildings, industrial structures, telecommunication towers, and outdoor equipment. So during my 8 years in the industry, I have come across problems in all these applications. So you can see in 8 years, I had to encounter problems in all these areas. So if a person who's living in a particular place for 10, 15, or 20 years, you can see there's at least once you can encounter a lightning strike. So it's inevitable. So there's a high chance where you can have problems to your structure and as well as to your internal systems. So the next question, what standards to follow? So it's the golden question for us to design. So the standards are to design actually, to design, maintain, and also to audit as well. So, I think I have to step down to university students' perspective now, because I know that these industrial terms are not quite familiar to you, and the intention is to get you more familiarized before you stepping into the industry with this prior knowledge you shall possess. So designing is a process where you have to come up with the sketches, number of items, and the details. So when you are going to buy a laptop, say, so you are concerned about lots of parameters, right? You are first worried the chipset manufacturer, Intel or AMD, right? And what's the generation, whether it's i3, i5, and if it's which gen, 10th gen or whatever, and your RAM, right? And hard disk, and whether you have this, other parameters like whatever peripheral connections you might have, the HDMI, number of USB ports, whether it's USB 3, 2, likewise, and the graphics card. If for gamers, you are concerned about graphic cards, if it's a GeForce, like whatever. Likewise, there are lots of parameters you are concerned. So similarly, when you're designing a system, so these parameters will matter to you when you're designing a lightning protection system. And maintaining, once you construct a lightning protection system, so I have to include the key part: construction, design, construct. Once you design something, you have to construct it, you have to install it, and once you install it, you have to maintain it. Otherwise, the purpose will be lost. I'll say why you need to maintain them, and once you, while you are maintaining, not once, while you maintain them throughout your lifetime of the facility or the lightning protection system, tentatively you have, not tentatively, periodically you have to conduct audits to check the compliance of these, the compliance, this term compliance of this, of our LPS with the standards and integrity with we give as built drawings. Once you construct something, the contractor will give the owner certain document. So this, why I am focusing on these terms in this session is because you are going to design a system. So when you are designing a system, in industrial aspect, you have to have some sort of idea, or at least you should have heard about what documents you will be handing over as well, because this is a broad subject and broad application. So just designing it on a paper or laptop is not enough for you as an engineer or a future engineer. You should have some understanding what you will be delivering to your client. So contractor will be giving the owner certain documents, and consultant will be overlooking this process. Okay, so consultant will be, this is an I, so he'll be looking at this process. So he'll be dealing with contractor and as well as the owner. Okay, so owner is hiring the consultant to observe the entire process of construction. So what I was saying is the contractor will submit certain documents to owner. So one of them is the as-built drawings. As-built drawings. As-built means how as it is made, how as it is constructed. හදපු විදිහටම කියන meaning එක තමයි තියෙන්නේ, right? So it means how as it is constructed. So once you construct it, you say, so this is how I constructed. So like if you construct a house, you give particular drawings to the owner. So this is how it's been constructed. Like, so this staircase and this entrance. Like, so you give all the drawings, all the layouts. So these are the as-built drawings. So we have to check whether the existing components are as given in the as-built drawings, because we are not going to design the entire thing again and again during audits. We have to check the compliance of the existing lightning protection system against the updated standards, and integrity with as-built drawing. Because let's say like IEC published back in 1999 is not valid to 2010. IEC 62305 standard is not no more. So this is, it's like 19 something. It's not valid to 2010. So you have to update the requirements, the parameters, and as well as all the assessments according to the updated standards. So therefore, you have to check the compliance against the updated standards. All right. And apart from that, you have to check the integrity of the existing systems with the as-built drawings. So you can see we are focusing this lecture towards designing. So this is no more a lecture on lightning protection systems, although the slides are oriented and prepared to give a basic understanding of lightning protection systems. The details we are discussing beyond the slides is about designing. Why we are designing? So what are approaches? What will be the outcome? And also, once we design it, so we are preparing drawings. Once we construct it, we are giving as-built drawings. So after that, somebody will come, a consultant will come and check the integrity of our lightning protection system. So therefore, as engineers, you shall keep in mind how to prepare the drawings, what components you shall include in the drawings. So this is the whole design process. So without discussing this, just doing the calculations and doing something on AutoCAD is not suffice to this approach, because we have to maintain and build the approach in university students, which we learned during our industrial practice. So for our interns, our trainees, that what we are trying to give, and also during these visiting lectures and guest speaks. So that's what we are trying to transfer you to. So I believe you get the intention of this workshop. So we'll move forward. And in few minutes, we'll be having a little bit of break. I hope the moderator will allow me for that, right? Moderator, I hope we can have a break in a while after I explain once I get the approach to the next topic, to refresh our minds, better have a break. Would you allow me for that?
I'll send the message too.
Okay, all right, okay. Okay, so please don't take this slide in a wrong manner. I'll speak what the intention is and what my idea is. Trying to hide this, disable, hide. Okay. Okay, hope you can see the entire slide, right? Can somebody confirm?
Yes, we can see.
Okay. So what standards to follow? So actually, when you get to an industry, you will get to know that there are lots and lots of standards. In Sri Lanka, you have, I'm sorry. In Sri Lanka, you have Sri Lanka standards. In India, you have Indian standards. In China, you have Chinese standards with different names. And in UK, you have British standards. And in Europe area, majorly, they are convenient to IEC standards. And in France, for specific occasions, they have French standards. And Australia, New Zealand, they have ANC standards. So likewise, for each and every region, they are abiding by a particular range of standards. So therefore, do not confuse these standards, because you as an engineer, you are learning universally. You are not learning to a particular region as an engineer. You will have to adjust yourself to whatever standard you have to follow to the particular region, because you have to follow the rules in the area. Simply, you have to follow the rules. You cannot live in, let's say, UAE. You cannot live in UAE experiencing the same rules and regulations in Sri Lanka. Simply like that. You are not allowed to break road rules like in Sri Lanka. So the punishments are quite, we'll say, if you say really bad, if you're gonna break the rules, not unlike in Sri Lanka. So same with these standards. If you design a system and if it has failed and caused a catastrophic event, whatever the damage evaluated, you have to compensate for that. Your professional license could be cancelled. You could have to pay a penalty. You could be even imprisoned. So likewise, the risks are really varying according to the particular region. So these BS, IEC, French, ANC, in Sri Lanka, whatever standards. In Sri Lanka, the thing is, with our current systems, the consequences are not that much harsh, but in future it will be. In other countries, these are quite strict. So my intention is to give you understanding that there are different standards in different countries and regions. So same with lighting production system, there are predominantly two standards which the industry discusses. So there are French standards and IEC standards. So don't take this image in a wrong manner, because it's not, what I am meaning is not to refuse it or to criticize that it's been refused. Okay, I'm just as a third party or in a third perspective, I'm trying to say what's been practiced in industry. So the French standards are there, and also IEC standards practiced by now almost major countries in the world. Even Sri Lanka is, we are also the consultants and the clients, institutions are asking to align with this. In IEC, you have this, there are several standards. So they are harmonizing. So, we say they are harmonizing the regulations to IEC, because all are trying to come into a common ground. The French standards are there in lighting production systems, and IEC are there. So in Sri Lanka, as consultants, as the first approach, what we are practicing is IEC standards with its proven approaches. And these are coming with certain certificates, with laboratory tests likewise. So if somebody needs something to be done with French standards, so we can consider that as well. But there's no particular rule in Sri Lanka, or no gazetted rule to have it with IEC. But that's actually the part of the consultant and the project, the project owner or the client to decide where to go. Okay, so the preferences are varying from consultant to consultant, from the project to project, from client to client. So these are to be mentioned in specifications, project specifications. Specifications are like what I mentioned about laptops. So these details. So this project to be done, or the design to be conducted as per, we say, as per what IEC 62305. So likewise, it shall be provided in the project requirement, or if it's gonna be a bid or tender, so that has to be mentioned in the bid document. So it shall be mentioned, or either engineer shall raise the question to which standard you are expecting us to construct, and like say if we are saying we are preferring IEC standards with the conventional lightning protection systems, or either you can go for French standards. So give all the choices they have and come into a conclusion, maybe with the pricing and all. Yes, okay. And the most important thing is you have to abide local authority regulations. So that's the key component and the key requirement. Whatever it is, you have to follow the local authority regulations. So in Sri Lanka, we do not have particular regulations on this requirement, but it's up to the consultant, and it can be negotiated. So today we'll be discussing, or we'll be designing our lightning protection systems as per 62305. All right, IEC 62305. So you shall keep this in mind when you're going to design. You do not have to memorize it. Do not memorize any like standards unless it's been an essential code like BS 7671, which every designer in Sri Lanka who designs electrical installation shall keep in mind, that BS 7671 18th edition. This is something you cannot forget. Okay, this is mandatory for you. But when you're discussing about other standards, you can refer what are the standards. But if you're practicing in the industry, then you shall have certain, at least an understanding, the approach, the major key ideas in the standard to conduct the designs. So that's why you have expert areas in certain fields. You cannot design everything in electrical installation as an engineer. You have certain expert areas, right? So we are in let's say medium voltage, low voltage, so high voltage, or you are in solar, or you are in wind. So likewise, you have certain expert areas. So only once you get that expertise, or let's say at least an approach to an expertise, not veteran expertise, because to become a veteran expertise in the field, you have to follow more than 30-40 years of research or practice, continuous practice as an engineer. So that's why actually I mentioned when giving introduction about me. So we are practicing in this area, and there are key experts in the industry who are basically in the academia, who are providing inputs to the engineering field. So with keeping that in mind, so you have to follow IEC 62305 for designing or maintaining or even auditing the lightning protection systems. Okay, with that, I believe we can have a small break. You can, if you have any question, you can come up after the break. Dinwanti, so shall we go for like 10 minutes break to refresh ourselves?
Yeah, let's have a break.
No, yeah. So I believe we can go for 10 minutes break, right?
So now you will be having a 10 minutes break. So stay with us. It's over to you, sir.
All right, so we'll resume from where we stopped. Hope you can see the screen.
Yes, we can.
Okay, so going beyond the standard we mentioned, IEC 6205, it has 4 parts, right? So I believe, sorry. So I believe you have already learned about this. So there are 4 parts in the standard. And when you come to designing, it's with the external protection and internal protection, you can get knowledge about from these. And first part is about general principles. Okay, so I'll quickly go through the standard as well to give you certain understanding. To have an overview about the parts, you have general principles and the risk management. Part 3 is physical damages to structures and life hazard. The 4th is electrical and electronic systems within structures. So I mentioned you that our scope of a LPS is external and internal both, right? So when it comes to internal systems, this IEC standard also give you certain guidelines, and as well as BS 7671, which is for LV systems, it gives particular guidelines and regulations that you shall follow when you are installing SPDs and the required protective devices. So in the BS 7671 18th edition, you have this part added about internal systems. So we'll go beyond the basic overview, and to mention that the approach of this designing is really important. What's the design approach? So before going into the particular designing and drawing, you shall know what's the approach of this designing, because at least you should have this approach in your mind. Without this, whatever you do in the industry or in the university will not matter and will not be effective. So please keep this approach in your mind, that why we are doing this and what we are going to achieve. So when you are designing something, you have to achieve something, right? So your achievement is to manage the risk. In business management, I believe you have learned about this risk management as well. So similarly, you have to evaluate the risk and take actions to mitigate it. Otherwise, you have to absorb or accept the risk. So as engineers, what we have to do is evaluating with the risk and trying to minimize or mitigate the risk at the best possible ways. So the next part is the physical damages to structures and life hazard is considering what are the damages that can happen to structures and the lives. So we discussed these hazards in our earlier topics. So that's why we discussed and showed you what are the possible hazards or the possible impacts to these important aspects of our business or a community. So it could be a business or a factory or facility or even the community. Okay, so we'll go through the basic principles. So these terms are coming under the design aspects. When you are designing, you have to have an understanding what sort of lightning flashes that can happen all around you. So based on that, the source of damage is mentioned. The sources can be the flashes to structure itself, like here, or even near the structure, right? So this is to service. So this is near a structure. This is, yeah, flashes near structure. Or it can directly apply or directly hit a service line or even near a service line. So according to source of damage, you can have different impacts and consequences as well. So the type of damage, once it's been struck, there could be damages. So the sources are given from S1 to S4, and the types of damages could be injuries to living beings and the physical damages like what we already discussed into the explosions, fire, and likewise, and the failure of internal systems, right? So these electromagnetic impacts could fail our internal systems. And so how to evaluate? We will go just now go at a rapid pace towards our designing part now, because now you already know the principles. The next part is to evaluating the risk. So this is the step 1 of design. So there are 4 risks, and the type of losses are known now, and the type of damages are also known to each of these losses, right? So for instance, loss of human life could be injury of living beings, or by physical damages, or failure of electrical and electronic systems. For instance, you might be thinking why this is coming under this loss of human lives. But once the electrical and electronic system fails, the persons who are using it might also get an impact indirectly. It could not be a straight away strike, like when you are being hit by a falling raft or a fire caused by lightning. So these are the potential ways of you could lose a human life, or you can even lose a service to the public from physical damage or a failure of electrical or electronic systems. Likewise, since you, I believe, already have these notes and these sketches with you, when you're designing, you will have to go through what sort of damages and when you're evaluating them, and also loss of economic values. Okay. So step 1 is, as I mentioned, is to evaluate the risk. What you have to understand and keep in mind at first is that this is an iterative process. Okay, so this is an iterative process. So in this iterative process, you have to check and establish certain controls, measures to check again whether it's been achieved. So that's the concept. So you have, initially you have a particular building. Let's say if you have a building. So you're going to evaluate the risk now. So according to the area it's located and the sort of process going on, the contents and the people. So you are evaluating certain risk level. So this is this much. Okay. So to achieve the risk probability, actually the probability of risk. So when you're needing to make it lesser than 1, you are trying to introduce certain parts to the building, have a lightning protection system and having SPDs, right? And you you might be introducing fire escape plans to people and having lesser time you're staying near a down conductor. Likewise, you can introduce certain measures to reduce these risks. So likewise, when you're calculating again, you can come up with a particular risk level. So one parameter which you are when you are establishing is this lightning protection system. Okay, so the process is like this. You identify the buildings or structures to be protected. First, you have to lay out. So what are the buildings? What are the structures we are considering? And the identifying the relevant types of damages. So it's a risk assessment. So you have to identify the risks. And for the risks, you have to calculate the risk components. From RA to RZ, you have components. These equations are given in the standard, and I will show you next. So you have to refer this in standard. And the RT is the tolerable risk, and the R is the calculated risk. Okay. So once you calculate this, if this R is less than R greater than RT, if it is no, that means if your risk is less than the tolerable risk, so building or structure is protected. Good. So if it's not, then you have to introduce certain measures. So if this is larger, then you have, it's asking if your LP is installed. Yes. So whether you have these SPDs and other measures installed, and if it's not, then you have to consider these next properties. And likewise, you have to follow through these measures, these risk levels. So these are actually the measures that are be counted as risk components to other process. We will go through this. So as an overview, I'm telling you what's the approach and what's been practiced. So likewise, you are trying to correct it, and you are going to calculate the new values of the risk component, and now check whether your risk level is less. So that's the approach. Okay. So prior to going to that, I will show you. I will show you the standard, and there's a summarized calculation which we'll be doing. Okay, right. So this is a 2006 version. So I'll show you 13 version as well. Okay. So in the standard, you can see this is bilingual standard. So you can see. So when you practice, then you have to go to the standards when you're designing them. In the industry, there are certain norms and terminology you can have to be familiar of. So first, it will be giving the definitions. Okay, for the terms we are using in the design process, suburban areas, when it comes to SPDs, these terms are coming in, where input standard voltages. Likewise, the definitions are coming. Okay, so LEMP Right. So we saw this in a slide as well, electromagnetic impulses, and it's telling us what are the physical damages. All the terms are having definitions, and this RT, tolerable risk, that's the maximum value of the risk which can be tolerated for the object to be protected. All right. And Rx is the partial risk depending on the source and type of damage. So likewise, you cannot memorize these parameters. So one thing you can do is to go through the standard and do the manual calculations, or otherwise to make it more effective, you have to prepare a calculation sheet based on the equations provided in the standard. Okay. And the other option is there are softwares that are published to calculate these risks with certain level of complexity. Some are not comprehensive, but can give a good ballpark figure about the risk levels. And for instance, other softwares are also now coming up with these add-ons of lightning protection systems. So anyway, you can have certain amount of understanding by going through the equations and definitions. And now we'll see how it's been assessed. So you can see this under chapter 6, assessment of risk components. You can see the Rx is calculated like this. I'm not going through these calculations each and individually. We would not have time. Therefore, I'll give you a basic understanding about the presence of equations, and I'll show you the summarized calculation sheet, which you can practice. Okay, so for the D1, D2, D3, damages to living beings, physical, likewise, and the partial components are given there. So this Rx is the general terminology. Rx means X could be anything. X could be A, B, C, likewise. So this R is calculated. The risk is calculated based on the number of dangerous events per annum. So you can remember how I calculated the possible hours of lightning, like your observation period. We calculated annually how much of hours you are exposed, your potential to expose to lightning. And the number of dangerous events. The second is the probability of damages to a structure. So this is really important. You have to calculate the probability of damage. So this probability will be caused by, because when you talk about the damages to a property, it could be depending on the structural elements, or could be the contents kept inside, or the measures you already have taken to mitigate the damages. For instance, say your fire protection system. If you have an automatic fire protection system, then you have like some sort of good measures implemented already to identify a fire risk and to eliminate that. So if you have the structures with reinforced and the properly protected shells, for instance, like if you have a warehouse with the explosives, then you have to construct it with the proper thicknesses and the structural elements which can withstand those pressure waves and heat waves in case of explosion, but not completely, at least to mitigate the effect to external areas or in the perimeter, the residences in perimeter. So L is the consequent loss, likewise. So these are explained in these annexures and further calculated, because this is a general equation and these risk components are calculated with this concept: number of events, probability, and this consequent loss. So losses are, this L stands for losses. So according to the losses, these are categorized. Okay, I believe you get some understanding the concept of this risk calculation, and we'll go through. So these all are connected risk components due to flashes to a line connected to the structure. This is according to source, the source 3. So according to different sources, like we mentioned, to the structure, near structure, to the service, near service, likewise, you can have different types of risks. So all these risks are calculated with because you can see the same concept is used: number of events, probability, and the loss. Number of events, probability, and the loss. So these calculations is the same. The number of events you calculate could be customized, because you are when you're calculating near line sources, like flashes near the line, you have to deduct the other events. So likewise, the number of events is calculated depending on the particular source. So we see the English version here. Yeah. So you can see demonstration. Okay. Yeah. So to the structure, near the structure. So all these are values are given in the clauses A2, likewise. So we'll be extracting these clauses to our design, because designing is something you have to apply from the basics. This approach you shall be familiar of, and the probabilities PA, PB, PC. So these all are categorized over here. Nothing you have to memorize actually. Okay, so while you do a project, while you are engaging something, then you will be familiar within that period of time, or maybe like, let's say like few months afterwards, then gradually this memory will fade off, but still that concept shall be within you to conduct the next project. So only refreshing the knowledge about these terms. And if you have already established the calculation sheet, then you would not have to go through this again and again unless there are changes in the standard. So these are the calculations. During the calculation, we'll see what are these. Okay, so this is the overview of risk calculations. So it's giving all the details, how to calculate these collective areas. So this AD, just put into your mind what while I say, these are the collective areas where the surges can come near the structure. So 3 times the height it considers, likewise. These collective areas, this algorithm they are practicing with these empirical formulas. Okay, so depending on the application you have to follow. So what sort of collection areas you have to come up with. Yeah, so about the internal system, impact on internal systems, and yes, how based on how your structure is partitioned, if how it's distributing the surges to your internal equipment will matter, you know. So if you have nothing partitioned, then the entire thing will come in. Like this partitioning means the separation electrically or taking proper measures for surges. Okay, so we'll just go through. So even when you get a standard like this, so just first go through the standard to have an understanding about this story they are saying, and their approaches, and what are the terminologies, what are the components, likewise. So you have to go through them. Okay, so I'm accompanying you through the standard to make you available, make you able to conduct complex designs after our workshop today. Okay, likewise. So these are those values which we discussed. Yeah. Depending on the applications for hospitals, likewise, this values are given for the zones. I'm sorry for the noises outside. My premise beyond my control. And these zones, according to the zones, lightning protection zones, the risk levels are given for the apartment houses. The risk tables are given. Yeah, you can either do the calculations and refer these tables at once. Yeah, there are case studies. They're actually taking an examples for the apartments, hospitals. Likewise, they're taking examples. All right. So this is the outline of risk calculation. So I'll show you the calculation sheet now. Okay. Can you see the Excel sheet?
Yes, can see.
Okay. Okay. Now is the important part. How you implement it. Okay. So this is what we implemented based on the calculations in the standard. So you can come up, you can create your own calculation sheet, then you will get deep understanding about the individual components, risk levels, risk parameters in the standard with proper calculations. So you can see if you take, these have been calculated like this, right? So taking risk components. Okay, right. So we'll see in risk calculations, what are the factors you have to keep in mind. Okay. First thing, the structure, about the structure, the characteristics of the structure and its environment. Because once you are given a structure, you will have to evaluate the and see. Zoom it out. Okay. So you have to see what are the parameters of the structure. So parameters of structures are, dimensions would be length, width, and adjacent structures, the structure of the height of the structure, and also height of the adjacent structure. Because if you're having a service line, let's say, let's say if you have a structure, and if you have an adjacent structure, let's say it's the transformer. So you will be getting, if you're having overhead lines, you'll be having this. And if you have cable tray, let's say you have a cable tray. So your cables are coming. Or either you might be having underground cables. Anyway, so you have this adjacent structure. Okay. So sorry, adjacent structure, HA, my building height. So these are the parameters. These are like a recent study conducted, and the structures and the parameters, length and width in meters. Okay, and the location factor is also given. So according to location factor, you will have to select. So according to either it actually considers in what sort of perimeter your structure is located. If it's a taller structure compared to the peripheral objects or trees, so it's a considerable risk. So if it's a a shorter structure, then you have a lower. So that's the basic understanding, but they are interpreting it with certain values and parameters. Okay, so this is the, let's say this is a calculated risk. Okay, so this is a calculated risk. Yeah, and I kept it freeze and we'll see what happens. I believe this value is linked to each. No, it's not linked. So okay, so CD value, this location factor. You can see the parameters are given there. So we'll have to okay. This is not even, yeah. So some parameters have because depending on your other parameters, the effect of some particular parameters will be negligible as well. All right, that's something you have to keep in mind. Not all parameters have the same weight. Okay. If you have class 4, if you have, this is not changing, but let's say we are increasing it to 0.4. So you can see the risk has increased. So you can see it's, this is the same value mirrored from the final value. It's simply a mirroring of the values. So the risk class is really important. So I'll show you what is the lightning protection class. It's really important for you. Elemental factor actually in the lightning protection systems. We are first going through this risk calculation, and soil resistivities are also given. You know, soil resistivity is a property of the soil, the inverse of the conductivity, how resistive is the soil will matter to us, and lightning flash density. So this is also very crucial point. If you have, let's see, it's simply doubled, right? So this is unique to a particular area, to a given area. This is unique. So this NG is calculated from 0.1 into number of thunder days per year. So you have to refer the thunder days per year in your geographical area and see what number of thunder days will be there. So for that, I will show you again a map of thunder days published by Meteorological Department. Okay. Well, yeah, I'll show you. I'll show you. Okay, this is data published until 1990. You can see which are the areas having large number of thunder days, annual thunder days. So there are maps with seasonal thunder days from period to period. And also there another image which I extracted from a research paper. Can you hear me?
Yes, we can.
Okay. Thing is, I cannot see the controls. Okay, and I hope you can see the map as well, right?
Yes.
Okay. Okay, and now moving back to the calculation sheet, you can see number of annual thunder days per year will be counted. This is, let's say, 1 to 5. So it will suddenly decrease if you have lesser number of thunder days per year. So this is measured actually number of flashes per square kilometer. You have thunder days collective for an entire area is not the correct value. You have to consider them per kilometer area, number of flashes per year, annual flashes. Okay, so there's another map I will show you during an example. And the consideration of internal systems are also there. If you have shielded wire, then what sort of intersystem failures and to the connected services, this is associated with equipotential bonding measures. So this Li value is discriminated and given in the selection table. So different parameters you have to consider. And if you have low voltage services, you have to consider the length of the line and how it's installed, if it's buried or overhead. Depending on that, your factor will be varied. And what sort of transformer and how the shielding of cable is done, and also the withstand levels of your equipment. If you have sensitive equipment, it's like 1.5 kV. You can refer these values also with BS 7671 standard. The minimum withstand values you shall maintain, and you have to keep in mind when designing a system is given in BS 7671 regarding low voltage part. So the service line from adjacent structure. Yeah. So another thing is these telecom lines. Okay. I'm sorry for this dark color. Some had been, I think, modified. Yeah, this telecom lines is another service coming into our premise. So a surge can be distributed to the premise. So that shall be also counted. Yeah, so inside the gantry means these are customers. Actually, the zones had been defined according to the project. So this is a gantry we considered medium voltage gantry. So it will differ according to application, the zoning, but the considerations you have to keep in mind will differ. Okay. So if you have power and telecom come into that, it will matter. Now the calculations are being done likewise. To the structures, power line, telecom, these equations will play the major part. I believe we shall not spend time on explaining each and each parameter and doing application, because the equations are given there. You simply have to put the equation and get the values. Okay, only thing is when you are having complexes, not single buildings and likewise, so you have to consider what sort of scheme you are going towards. So how you consider a particular area, either you are taking a specific building or a collection of buildings. So that will depend on the your concept of installing the lightning protection system itself. Okay, so either you are going to have separate buildings, or if you have considered it as a whole. But if you are connecting it with the same earthing system and this, if you are bonding them, then you have a risk, associated risk with that. So that should be taken into account as well. So these are the calculations done according to the standard. So what you have to do is, if you have all rest of the things as mentioned, where you can play in this calculation is the lightning protection class. The first thing you can do is this lightning, because you cannot change number of people coming to the premise. And if you already have a fire protection system installed, you cannot, unless it's unavoidable, you have to now consider as the lightning protection system designer, then you have to consider the lightning protection class. So depending on the class, it will play a role as we discussed, right? You can see how it changes. So based on that, you have to select which protection class will satisfy our requirements, or what sort of class will be required to address the available risk at the premise. Okay, so if you have a risk, so that should be covered with the class 1. If you have a low risk, then it can be covered with simply a class 4 system. So that's the concept. So you have to, that's why I said this is a recursive process. You have to check which sort of protection class you shall practice. You should apply to minimize the risk associated. Okay. So about this lightning protection class. So all these all are interrelated, and without this, I cannot move forward to other parts. And likewise, without focusing on this risk calculation, I cannot move forward beyond that part. So it's an associate knowledge. That's what I said. This learning is not a straight line. While we speak about this, there are other questions that will make an impact to us. Okay, so what are these lightning protection class? For the people who are not aware of, I will briefly go through. So there are 4 classes with particular ranges of lightning currents. The ranges with the class 1, you have 3K to 200K. These are just numerical figures. Do not stick with these, because these are updating also with the researchers and data, meteorological data. So these will be updating, and because these are being derived, you cannot measure these currents. These have been derived with certain scientific methods. So class 1 has the highest number of maximum possible lightning current. So class 2 is a bit lesser. Class 3 is somewhat lesser, but class 4 has a narrow band as well. All right, so I prepared this based on a particular classification of 4 classes. You can refer IEEE standards as well. So this is just for your idea. These figures will vary depending on different studies that will be conducted. Okay, class 1 is actually the worst. I mean, class 1 in the perspective of the risk, the required risk. So it has a higher risk of higher risk associated with this, the particular premise. So you need a higher class. It's like first class. So a first class student will be required to conduct a particular research. So likewise, class 1 will be required to address a serious issue. But class 4 or class 3 is adequate to address a quite a small issue. So keep that in mind with these classes. So designing of external LPS, we have already started with the risk calculation. We started with the characteristics of the structure to be protected and the risk assessment. So we just had a look. We did not go individually because it itself will consume like 5 or 6 hours. Definitely, if I'm gonna go through each and every detail, it will take more than 5 or 6 hours. And so that's why you have to do the calculations and attempt calculations. You see what to be conducted. And the selection of type of external LPS. So this is the next question. We have type of external LPS, the type of materials. All right. So when it comes to type of materials, you have to consider certain mechanical, chemical, and electrical properties. So all these parameters are important, mechanical and also electrical properties. Type of materials. So once we are going through the details of this, we'll discuss problems related to them as well. And the sizing of lightning protection components. So what sizes? And also there are natural components. So natural components. So these are things we have to put in. We have to add in addition to our structure. So we already have a structure. Okay. We already have a structure. Let's say like this. We already have a structure. So if we have a steel roof with adequate thickness, okay, with adequate thicknesses, so this itself will, if you have proper bonding to these down conductors, and if you have proper earthing of them, then you can consider this as a natural component. This roof is a natural component. So you can consider certain pipes with thicknesses if they are not being used for other services, but obviously you have pipes for a particular purpose. So therefore, if you are using pipes, it's a matter of fact, and it's also mentioned in the standard as well that you cannot use the pipes considering the service it is being employed at the moment, but you can use structural elements. Okay. You can use columns, the reinforcement inside, also as the natural components, provided that you are having particular continuations, right? You should have, because when you lay columns, you have these overlaps. So these overlaps shall be properly bonded, electrically bonded. Okay, so we'll discuss the questions later on with the individual slides. And likewise, what I explained is the natural components. So you can have what's already been in the building to be used as our components in the lightning protection system. Okay, and the now other parts. So what are the other parts? Means the key elements of lightning protection system. So we'll see. Yeah. So next slide will give you understanding about individual parts. So just keep in mind about this air termination system, down conductor system, and earth termination system. Okay, keep these terms in mind. So now we'll see the slide. So you have air termination system here, and the down conductor system, and the earth termination system. So air termination system is what is exposed to the sky, what is exposed to the charge clouds above the ground. So it's shielding our building. The down conductor is to, so if you have a cloud, so, these are what shielding. These are what streamers and what is neutralizing effect is imposed. So this is taking care of this process. Okay, this whole thing is taking care of our clouds. And you have down conductors where these charges that are supposed to be neutralized throughout the process to be delivered to the ground, that's done through these down conductors. Okay, these are external down conductors. You might have also down conductors within the columns or other structural elements, or let's say even the steel columns itself, that could be down conductors, like I mentioned. So you have these down conductors, and can be the next part is earth termination to properly disperse the current, this light, not actually the exactly lightning current, but the continuous discharging of the clouds, this discharging process of the clouds, to make the clouds exhausted out of the charges to continuously, and this is to be dispersed to the ground through the earth termination. Okay, sorry, not here, external to the building. Yeah, so this is dispersing the static charges developing at the air termination, and that phenomenon to be conducted to the down conductor and dispersed to the earth through earth termination. So that's the concept. Okay, so before going to that, we'll see that process. So we saw how the air termination, air down conductor termination is laid, and air termination, you can have different subcomponents, right? So you can have a mesh. Okay, mesh is something like this on the rooftop, or you can have vertical air termination rods, right? Or overhead air termination wires. If you consider this, you can have, we call this catenary wire. Catenary wire. So these are not necessarily B2B. Also keep in mind that these are not necessarily need to be constructed on the same building. Okay, you can even have a building and a structure and have a lightning protection system which never touches the structure. For instance, like this, you can have this catenary wire. This is the building to be protected. So this is the air termination here. Air termination, and you have down conductor, and you have earth termination. Okay, so in a substation, that's what you see. Your lightning protection system is not installed on transformers, circuit breakers, CTs, PTs. They are not installed on those substation equipment, but you are having separate air termination, these catenary wires mounted on top of these steel lattice structures, right, in the substation. So likewise, if you have even certain storages with explosives and all, you can have this isolated system. We call this isolated systems, isolated LPS. Okay, so depending on the application, you can select whether you are going for an isolated LPS or a non-isolated LPS. So these are the types of air terminations you can use. So immediately I will do a small design with these air terminations. after going through that concepts of evaluation. And you can have these vertical air termination rods and overhead air termination wires, and also natural terminations, right? So if you have a steel roof, right? If you have a steel roof, but you have to make sure of the thickness. If you do not consider about the thickness, then you have to absorb the risk. So if it says like it shall be like 6 millimeter thick, so you have to make either you have to make sure, or it says that the standard itself says that, otherwise it will cause punctures. Punctures means during a lightning flash. So there's a risk of puncturing of the roof. So I'll show you that close in the standard. Then you can have a better association with the standard as well. So, and yeah, termination, I'll show you. Yeah, so you can see minimum thickness of metal sheets or metal pipes in air termination systems. All right. So depending on the material, it defines the thickness. Right. Okay. So in order to prevent a puncture or a hotspot or ignition, so if you need to prevent that, then you have to make sure these thicknesses are maintained. My gosh, it's like 4 millimeters, 7 millimeter. Like consider the weight of the roof, it will impact, right? So they say because it's a lightning current, then you have a minimum cross section to conduct it without causing higher temperature rises or sudden temperature rises, which can melt the spot of strike, which can cause punctures or even hotspot, or which can lead to ignition later on. So if you have an ignition, then it could be catastrophic, because with the ignition in the roof, it will fall off onto your stored items or pile of items, then it can spread a fire as well. So these are the design aspects. These are the design key components you have to consider. So if you're having a roof and you need not to have a puncture, then you have to maintain this. But these are quite impracticable when you have metal sheets, because you have now metal cladded sheets with these wafered roofing solutions. But if the puncturing is allowed, you go with these thicknesses. Only for metal sheets if it is not important to prevent puncture, hotspot, or ignition problems. So depending on the items that are being stored inside the facility, then you can go with this as well. But you have to consider other aspects of the LPS with that. So going back to the slide. Yeah. So natural components, and the next one is a down conductor. So design of down conductors we'll be doing, and number of down conductors required, that's coming under the same design, and concealed or exposed. So beyond the number game that we'll be doing, these are some facts you have to consider, whether your down conductor is to be exposed or concealed, because with buildings, the architects are not preferring to have down conductors being shown to the viewers who are passing by. They need to have them concealed. Concealed means hidden, right? They have to be hidden or exposed. So as a solution, you can then go for natural components, so have a separate down conductor in the columns. So you can have a additional down conductor in the columns. So number required, we'll be checking with the design and natural components, like I mentioned. And earth termination, you can have different types of foundation to act as the electrode itself or have additional electrodes, and also have these natural components. But you have to take care of the integrity of these natural components. So I'll show you what are the natural components, and this internal LPS design will be doing later on at the end of the session as the time permits, because it's actually a separate subject, like expertise, not expertise area. It's actually a separate area we have to focus. This is also given in the BS 7671 standard, because now it's mandatory to be practiced correctly in Sri Lanka as per the Sri Lanka Electricity Act. So that's why it's mentioned in the BS 7671 standard. Okay, so we discussed this one, and now the designing part. So air termination, we can design either according to different methods. So we saw this method one, mesh method. So it's like this. If you have a flat roof, a slab, then this mesh method can be a good solution, but you have to consider the amount of materials, and if you have other components in this area, then you have to consider, and the walking passages. So this has to be considered when you're designing it with a mesh method, but it could be a good solution in certain aspects when you can't have air terminals all around the place. So mesh method can be a good practice. So mesh size is given, we'll see according to different approaches. So rolling sphere method is, this is evaluation method, rolling sphere method. So this rolling sphere is used to check out what are the protected areas and what areas are not protected. So simply it's like this. It's a sphere that we are rolling around the premise, and on top of the building, to see if this sphere touches any part of the building. So we have to either 2D or 3D, but 3D is the most effective one, as we evaluate, because building is not simply a cube or cylinder. They have complicated extrusions like this. So, and these have depths as well, right? So likewise, you have to consider different if you have extensions like this, so it's a different case. So 2D is quite hard with this, then you have to go with 3D evaluations. So you are going to roll a sphere and check out what are the affected areas and what areas require improvements. And the other method is the protective angle method. So it's more like a simplified method of this rolling sphere method. So we'll see what are them before we going to have a practical session now. So rolling sphere, according to the classes which we discussed from class 1 to 4, you can see the rolling sphere, the radius is varying as well, from 20 meters to 60 meters, right? You can see if when you have a class 1 system, you shall have a 20-meter radius sphere. It's like this. Let's say this is for class 4 system. So let's say this is 60-meter radius. So if you have class 1 system, so it's like 1/3 of this radius. So it's like this. Okay. So okay, it's like this. So you can see this rolling, when it compares to these two spheres, when you have a class 4 system, it only touches, it is standing on the ground and touches only here. So the volume protected by this sphere is called the protected volume. So you can see this volume is protected. Consider this as 3D, then otherwise if in 2D this is an area, but if you consider a 3D space, this is a volume. So the volume protected by the sphere is actually like it's like under the shelter, under the volumes which are not being touched by the sphere. So you do not have to consider these areas, because you are considering the structural perspective. So you have to consider these protected volumes. And if you consider this class 1, so if you say this is 20 meter, so if you have a 20 meter sphere, 20 meter radius sphere, you can see now it touches even up here, right? So it only protects this much of volume. You can see. So earlier it protected this much. Until this area was protected. Only above this portion is required to have. These are like additional air terminations. Okay, these are given here in color. These are the air terminations to have additional protection. So with this 20 meter radius sphere, now you need to have additional protection for these as well now, right? So if you have this small sphere here, then you can see, so it will stand there. Okay, so it can touch even that part. So you need to have additional protection against them. So it's simply like this. These buildings are in a different layer, and this rolling sphere is rolling in a different layer. So whatever this sphere destructs is destructed by the lightning strike, because it's like this. Your step ladder is coming from the cloud to this portion. I'm sorry, to this here, right? This is the leader. And we discussed about the streamers as well, right? The streamers are from the ground or the structure. So here it can, the streamer can go like this, or sorry, like this. If it's from there, it's only up to here. So that's why it's not impacted. If you take here to this cannot reach it. The streamer cannot reach this leader's closest end. This leader cannot come beyond this, because along with this leader, this stream is forming. So it's a concurrent process. So this streamer cannot reach this one. But here you can see, considering this one, you can see this copper can, because this radius 60 meters. So this 60 meter means that the length of the streamer, that's the analogical meaning, this length of the streamer. So even here, you can see when there's a cloud over here, you can have this leader here, and the rest of it about the streamer. Now the streamer is emitted here. So it's making sure that the streamer is coming from up the air termination which we have implemented intentionally to make it face this incident. Okay, unless if you did not have these air terminations, then what would happen is, when this cloud is above the ground, this will be induced, and even the streamers will come with over here. If you did not have, like, so that's the concept. If you have these components, then it will make sure that these have been properly grounded ultimately. These surges will be grounded ultimately. So that's the idea. So when we are doing the rolling sphere method, we have to do it with that concept. Okay, other one is the protective angle method. So bit similar to the rolling sphere method, but this approach is different. So if you have a building like this, and this is their termination. And it says that according to the height from the surface where this arrestor is mounted and to the tip of this arrestor, based on that height, this H value, you will have a shielding angle like this. And these 4 lines are for the 4 classes. Okay, if you have considering a particular class, then you have to go with a particular line. So it's similar to those relay tripping characteristics. So for different EMS values, you have different curves. So likewise, for different classes, you have different curves. So when you are considering a particular class, then according to the height, you have different angles, right? For instance, if you have, let's say this height is like 3 meters, let's say like 3 meters height. So 3 meters is like over here. So for 3 meter height, you can see for a class 1, you can see the angle is like this, okay, like 68. Okay, like 68 degrees. Like, okay, so when you are considering this angle, if you are considering the angle toward this area, so now you have to consider, now it's like protected over here because now you are considering the shielding towards the outer, right? Because you have, anyway, you have to have this cone towards the earth surface. Okay, so when this considered height is taken, let's say this is 3 meter, we'll consider this as like 20 meter. Okay, so for 20 meter, you can see the angle is like 21 degrees. So this angle is quite smaller than this angle, right? You can see that. And let's say if it's like a 25 meter, so what would happen? Pardon, sorry. This should be like 17 meters because overall it should be 20 meters. So overall this should be 20 meters. So then building height, we can consider 17 meter building. We are having 3 meter arrestor, then overall it's 20 meters. Then we are having an angle like this much. And let's say if this is 18 meters, building is not 17, then we have building is 18 meter. Then the risk we have calculated before, lightning protection level. This is the risk level. According to risk level, the required lightning protection level is class 1. If it's like that, okay, then the problem is you cannot protect this structure with this arrestor because this is not defining a value beyond that. All right. So if you are considering this much of height, then yes. If your arrestor is this much height, then yes, you can consider that, and you then will have that particular angle. Okay. And the problem is when you have a higher height, like when you go above this 17 meters with this 3 meter height, overall, if it's exceeding this 20 meter, because this curve is defined until here. And for a class 2, it is defining until 30 meters, and this is until 45 meters, and this is until 60 meters. So these values are equal to those rolling sphere radiuses as well. So if you are exceeding these values, so these curves are not defined. So you cannot create a protection angle cone using these graphs. All right. So for example, if you have this 18 meter building, then you cannot have a 3 meter arrestor because then overall it will be like 21 meter total height. Then you cannot define a protect angle for this application. So then you will have to make it shorter and check it out. And if you make it shorter, the problem is then this angle will be like this, and you will see that you are coming nearer and near to this edge. So if it's going beyond this, if this further increases, then your, let's say your arrestor is becoming shorter and shorter. Then if you try to draw the protection angle, then you can see a particular area is not protected. So that's what happens when you are going to design. So I'll show you an example. Okay. Let me show you an example. Okay, can you see this?
Yes.
All right. Can you see the AutoCAD? This means AutoCAD. Hello. Hope you can see the AutoCAD, right?
Yeah, we can.
Oh, okay, okay, right. All right. So this is a building. Let's say this is a building. And now we are going to install a lighting protection system. So with the protection angle method, let's say it's actually a trial and error method. You have to attempt few times. We'll get rid of this now. We'll only see this portion first. Okay. So if you have an arrestor, and I hope you have basic AutoCAD skills with you. So, and okay. So you can see overall, you have like 54 meters. And if it's class 4, meters, and if you have class 4, you have like this much of angle, right? 20, yeah, like 25. And I'll show you how to draw this as well. Like see, 26. So this is something I tried out yesterday to give you an understanding. So we'll see how we design this. So first we have the building, and we are coming up with a certain risk level. We have to calculate it first. And these are only the hatches come off. Okay. Okay. So this is our ground. So we are thinking of a particular with the current practice, you can consider this as well, because you have to first identify what's the height of the building. Now it's 51. Then if it's class 4, it will be all right. But if it's even class 3, then you cannot help with it, because this is not defined beyond 45 meters. If class 4 is all right, then if it's class 3, then you cannot evaluate it with the protection angle starting off from this edge. Then you might have to consider somewhere over here, right? If it's beyond that. So if it's acceptable, then let's say you have 1 meter, because 3 meter is having, it's almost like a floor level, right? So there are practical limitations as well. You cannot simply put like 4 meter, 5 meter, 6 meter lightning arresters. There might have, then you have to have proper mounting structures to accommodate that, or else you have to try to minimize these additional burdens you first have to do particular attempts. Okay, let's say it's like 1 meter. Earlier I drawn with 3 meter, but now I'm taking the example of 1 meter. So overall, this is 51 meter height building with 1 meter. That means 52 meters. Okay, so if we have 52 meters, so the angle is somewhere like 30 degrees. Okay, hope I'm clear to you. If you have 55, like say 52, so it's like, let's say assume like 30 meters. So you have to draw at an angle of 30 meters. Okay, so once you need to draw at an angle, so this angle is from this arrest plane. So what you have to do is to at, let's say some value like 20, and the degrees are measured from this rotation. That means anti-clockwise. Okay, anti-clockwise degree measurement. So if you need to have 30 meter deviation from the top vertical, then that means you have 270 until here and rest of the 30 meter over there. So that means like 300 degrees. Okay, so it's like this. So you can lengthen it. So it's like this. You can trim off the edge. So now you can see the protected volume. So the problem is, if you have, let's say, sometimes you cannot have the lighting protection systems installed right at the edge. So if you have it, let's say, if you need to have it inside, little bit inside to conceal, then of the snapping, now you can see how much you can move, right? So beyond this point, you cannot go because it will damage. There's a portion of damages potential. So this is the best zone you can go for. Okay. All right. So do it with a clear mind, because sometimes when we do it with rush, we might do certain mistakes. But have the basic understanding when we do it. So when we are considering the protection towards these surfaces, then your angle shall be considered based on the height from this bottom edge to tip. That's the height. So your angle will be more compared to towards the ground area. So you have a small angle to the ground level here, and you have a higher angle towards this building internal areas, because the idea of this is actually when you have, this is actually giving the idea of that rolling sphere which we considered with the step leader. It's considering what sort of areas it can reach. So if it's over here, you can see with this height, but with this surface lateral to the arrestor, there's a more chance of more protection chance from the arrestor, rather than when you're considering this vertical surface. For this vertical surface, it is all right, but for this lateral, you can see there's a much wider area of protection. So that concept can be further taken from rolling sphere method. So if we are going to apply the rolling sphere method now, so this will be a great example for us. So we considered a class 4 protection. So if we have a rolling sphere, so the concept should be, we have a sphere now in 2D. So the radius is 60 meters, right? We have 60-meter radius. So if you're having it, so if you're gonna move it, we can see what will happen. Okay, so you can see if it's gonna touch the edge. I'll show you how to properly draw this. So this is just for illustration. You can see the difference between the evaluation difference between the little bit of deviation. I'll show you how to exactly draw this. So you can see, although with the protection angle method, it is depicted to be protected by, but you can see with the protection rolling sphere, you can see there are unprotected areas. Okay, so this is a simplified method, protection angle method, but you can still see there are issues related to that. So to have it exactly drawn, you can use simple geometry. Okay. So 3D application is quite time consuming, and I don't think we will have time for that. We'll do it in 2D now. Okay. So I can simply draw a line from here. And so let's see. Now you can move it. So if you are auditing a system, then you can see like here, right? So this is a protection angle evaluation. So you can see it's always better to have some tolerance of provision when you are designing systems. If you are designing with protection angle method, it's better to have some sort of a provision, because if we are evaluating it with protection angle method, there's always a room for error found in protection angle method. So I believe I made it clear to you how to draw this. So all along the premise, then you have to simply draw this. So if we yeah, I'll draw it with an arc. That with an arc, start and radius. Yeah, start. Yeah, and my radius is 60 meters. So you can see how it's been made, right? Okay, so these are the protected volumes. So if I remove this, yeah, you can see and now the other problem is, let's say if you have, these are the design issues. So let's say if you have some sort of equipment mounted on the if you have certain amount of yeah, so if you have, let's say outdoor package unit mounted on top of the roof, so you can see this area is not protected. is above the roof is not protected, right? So there you will need to have additional arresters. You need to have additional arresters, like let's say 1 meter. Problem is sometimes we cannot mount them on top of the particular equipment. Then you have to have a separate, mounting mechanism. So it would not be sometimes possible to have it right above the equipment. Okay, so if we are gonna draw an arc now, you can see how it would behave. Okay. I'm sorry. So direction matters when you are drawing arcs. Okay, so now you can see it was eliminated, right? So if you have further and further equipment mounted on top of the building, then you'll have to consider them. So these are basic geometrical principles that you can incorporate to your lighting protection system designs. All right. So I'll show you the same can be done in 3-dimensional spaces when you're designing. I'll quickly show you and move to down conductor because now we already reached 11:53. Let me show you a 3D application. If anyone has any question from what we have discussed until I open the file, you can discuss.
There's a question in the chat box.
Mhm.
What's the best material to use for the LPS down conductors in high-rise buildings?
Okay, that's a good question actually. Is the question, yeah, is the person available so we can, because I need further input from the question raiser.
Vijay Ratna, I think he left.
He left. All right. Yeah, so these are actually good questions, I believe. Right. So he's associate member, so he's an engineer. So with the interest in the subject, he might have asked based on particular applications he's involved. So these are actually the practical questions you find and you come across in practice in industry. So when you are selecting the materials, so it will matter that what I mentioned. So when you are choosing down conductors and other materials in our applications, you have to consider the mechanical, chemical, and electrical properties all together. It's not just electrical. So if you're using down conductors, either you can use the same reinforcement. I believe students know about the reinforcement in the columns. So you can use the same reinforcements in these columns if you have provided required connection criteria, if you have fulfilled those connections. Because when you have those rebars, steel rebars in the columns, you shall have, for the structural requirements, you are having overlaps and you are binding or welding, having some coupling together. When it comes to a high-rise building, your rebar sizes could be like even 1.5 inch or likewise individual rebar. So you have plenty of rebars there. So if you're having them, So those toe steel are those, Dangaravane with those spiral steel that are being used for columns, rebars. So if you are having them, then you should have proper connections, right? And it will also matter with the environment that you are using it. In corrosive environment, and if the concrete proportions, because if you are having corrosions, then those contacts will have those weak connections. So that's not desirable. Then you might have to have dedicated conductors sometimes. So when you are selecting a conductor, a separate conductor, let's say if it's like a mild steel. So mild steel, if you take the chemical properties, so they are not alloys. The constituents in the mild steel are corrosive, right? So when depending on the application, you have to think of the materials that you are using. So having non-corrosive, but you have to have those connections, proper connections. Likewise, depending on the structural design. So because there are no straightforward answers to any question unless you have a discussion. So that's why I actually appreciated if the question raiser was here, so we can have a proper discussion. Then that would be better. So anyway, the mild steel have problems with corrosions, and toe steel have problems with those because being used for reinforcement. Then you have to have proper interconnections among these. Let me show you. So this is for the students, I believe this is really good. You can simply even Google and think so how these shall be incorporated. Can you see the screen?
No, not yet.
Not yet. Okay. This is actually a vast subject. We'll cover the design aspects at best. So you can see right now.
Yeah.
Okay, so it's like this. So these are the rebars. Okay, so you can see the cursor, right? Can you see the cursor?
Yes.
Okay, so these are the rebars you have seen even during construction of houses. So these are the structural elements. So if you're using these structural elements, then these proper clamping methods shall be used. And also, let me show you, when you go beyond, you can see you can use those connections, rebars. This is actually used for lightning protection down conductor. And when you are getting this to earth termination, you have links from the down conductor to outwards. So this this is when you are using separate conductors for lighting protection, which is mechanically attached to, mechanically and also electrically attached to our own structural elements. So that you have to keep in mind that this will be in contact with our structure. So if you are gonna link or connect our electrical equipment to some sort of structural elements that are used as the natural earth for the entire building, for earth meshes. So we have to keep in mind about this as well. So you can see how they are being linked for different applications. And again, I'm sorry for any noise coming from the external environments. Yeah, so you can see how this reinforcement and these conductors are being used inside the columns. So these actually are being practiced. The only problem is depending on the application and other structural requirements, you have to consider what are the properties, because the materials we use shall not corrode the structure as well. That you have to keep in mind when you are choosing materials. You have to make sure that the materials that we are using for lightning protection system shall never damage the structure. So that will be a real issue if you're gonna attach them without proper understanding. Okay. All right. I will show you a 3D illustration. So it will be interesting for you to have some understanding. So how long can we have more? Now it's already 12 o'clock. So what's the feedback from students? Are you getting something? At least one student may speak up. On behalf of University of Ruhuna, anyone can speak up. If you have any questions, just let's speak, because you might not get into this until you leave the university. Anyone? So did you get anything? Did you have any understanding? Dinwanti, shall we name somebody to speak?
Yeah, you can name.
Now you may name, because I'm trying to go through to show you an illustration, a 3D illustration we did.
Okay, maybe Ruanta, can you speak up?
So you can assign marks as well, with this.
Yeah, of course.
Based on the responses, you will be assigned marks. You will be given special marks.
Yeah, sure.
So that's how it should be conducted.
Maybe this batch has a good practice on Zoom sessions. They were done academics more than 1.5 years.
Yeah. Because since this is a workshop, this is not a lecture. So in a workshop, usually if I was physically present, then we'll be going to each and everyone. We'll be asking them to come up with laptops and do tryouts. But with this, this present situation, but still we need to maintain the effectiveness. And I think it was supposed to be marked with their contributions as well to the workshop. So the marks will be assigned. Yeah.
Niroshani?
Yes, madam.
Yeah, can you please speak up?
Madam, the question was not clear to me. That's why I'm not responding. Could you please ask it again?
Yeah.
Okay. Yeah, the question is actually So what's your feedback about what you learned so far about lightning protection systems? Was it clear to you? And do you have any questions, any confusions?
No, no, sir, it is very good. So to
It's
get
clear.
question, yes.
Yeah. So shall I ask a question?
Yeah,
All right. Okay. So we'll ask you a question at the end of the session. So anybody else? Because we need to make it live. Otherwise, my contribution will not be sufficient actually. So about this lighting protection system, Dinodhi, can you name somebody else? I have a question to raise. Just pick a name and let me know.
Nisal Dulanchana. Or else Nirmani Ratnayaka.
Hello, Miss.
Yeah.
Yeah. Hi, Irmani. So at your residence, when you have a lightning in advance, so what sort of experience you had with your electrical installation?
In my home areas, yeah, in hill country, so
Uh-huh.
there's nothing much effect for my home,
Uh-huh.
but also there are, no high risk of lighting experience here, but in Gaul, we experience very high lightnings, but in faculty premises, there's no issue.
All right. Okay. So I mean, when sometimes when it's about to get lightning strikes, so you might have experienced tripping of RCCBs, right? Trip switches.
Yes.
So is it desirable or what?
Yes, sir, of course.
Why?
Because of the protection of our equipments and all.
All right. Other question is, and have you also seen sometimes during lightning, you are getting sparks out of the socket outlets with that chiri chiri sound, sparking? Have you seen?
I'm not seeing.
Okay.
But
All right. So what do you think is the intention of RCCB strip switches?
that means then the overcurrent that flows through those devices.
RCCBs?
Yes.
No. RCCBs are for what? RCCBs for fall protection, right? So they are, like, to speak generally to all the audience, RCCBs are for protection against indirect currents of fall protection. Okay, it's a type of RCD, residual current device. So they are not supposed to get tripped during lightning. RCCBs are not providing protection against lightning. So it's undesirable. So that's why you need to have surge protective devices. So SPDs are therefore, that's what I told. Internal LPS I mentioned. SPDs, that's therefore those protection against lightning for our electric installation. So I'll come to that quickly. So you can see This is from, and because I had to rename the file to protect the privacy of our client, I had to rename. This is a factory premise, one of our clients. We conducted an audit as a part. We conducted evaluation of lightning protection, existing lightning protection system. So you can see, I'll hide this. So you can see the existing arresters, right? Hope you can see in red color here. You can see existing arresters, right? Okay. And now then we have to apply rolling sphere method. Rolling sphere method to evaluate the protected volume. So simply what we have to do is to roll a sphere. We have to roll a sphere all around the premise, only considering the existing air terminations and those provisions given. So you can see the effect of rolling sphere here. So it's like this. So I will put this on X-ray. So you can see there's an arrestor here. Pardon for any clarity issues. There's an arrest over here, and you can like visualize how a rolling sphere would behave. You roll a sphere around this, and you have a sphere around on top of this, and you can make it fall down this word and this word, and likewise you can roll the entire sphere all around the premise, right? So with that you can see what are the protected volumes and what are not the protected volumes. All right. So can you at least understand the outcome of the study? So the last student who spoke up, can you confirm, like, you get what I tell? Okay. So the green areas are protected volumes, although there are no buildings over here. Anyway, these are the protected volumes. So if it's protected, if the structure is within the protected volume, then it shall obviously cover it. It's like hidden under the tent of this rolling sphere. So these exposed areas are not protected. So it's an extension of that that 2D design we conducted. So it's a bit complicated, and it will take a lot more hours actually to teach you how to do it. But first, I think for your level, you shall be able to conduct this assessment with a 2D design. Okay. Then one thing, I believe that's adequate for the students at this moment.
Yes.
Yeah, because playing around with 3D will require certain, AutoCAD skills and all. So I think this is not the session to conduct all these basic principles. But I hope you get some understanding about these air termination systems. All right, to continue with our presentations quickly. So protection angle method is, hope it's clear to you. I will assume it. So we'll see with the assessment. And the next is the mesh method I mentioned. So, this is a mesh. Mesh is a single square. Please do not confuse it with the grid. So grid is a collection of meshes. A mesh is a single square. All right. So this mesh is having a different sizes according to our classes of LPS. While you have a lower class, like not lower, when you have a higher class, which is lower in number but higher in protection, it has lower size. You see, if you say this is a 20 by 20 mesh, if you're gonna improve it to a class 1, then you will have to divide it into 4 squares, right? You have to divide it in 4. Then, sorry. So then you will have 5, 5, 5, 5, likewise, and over 5, 5, 5. So your mesh size will be smaller. Clear? Your mesh size will be smaller. So that means you are consuming more and more of materials. You are having more materials. So when you go upward this, obviously the amount of materials will go high as well, because you need metals. So these days these materials are quite expensive. So these materials will go higher and higher when you have higher. But if you have the requirement to fulfill that, then there's no option but to have it. Okay. So when you have higher class, you have smaller mesh size. So you're having more and more squares over here, more and more squares over here. Okay. When you have higher class. So this is when you check this out, you can see this is combination of air termination methods. You have a mesh and you have these air arresters. So these air arrestor also no. So you have a mesh as here. You have meshes. So unless you have any other protection to be maintained, then there's actually no need of having these air terminals over here. But you have to make sure that all this is to the most edge of the structure to be protected. So when you are having this rolling sphere method, then you have to simply, then for the mesh, you cannot have rolling sphere method, because when you think quite logically, you can see for a mesh, you cannot define a rolling sphere method. Okay, that's why we have a separate method as mesh method. Okay, you cannot roll a sphere in this mesh. But when you need to evaluate the protection of these side elements, you can see there are ways you can, like this. You can see like this. So like this, you can understand. So these are these lines just to give you an idea about the contours. Okay, so this like this to give you understanding about the contours. So likewise, you have to use mesh method only in meshes, no other way. So you have to maintain these distances. If you have a building with like, if your lighting protection level is class 4 and your building is, let's say this 60 meter width, then you can have this 20 meter each. And if it's like 65 meter, then you have no option but to have a smaller mesh. There's no requirement to go for exactly these sizes. Okay, if you have 65, then you can divide this into a number of, anyway you have to maintain these minimum spaces, these minimum sizes. So then you can divide 65 by 3 and have it here. Will that work? No, because 65 by 3 is obviously greater than 20. Then what you have to do is to increase the number of these squares. Okay, like this. Then your approach will be different. So likewise, what you have to maintain is minimum mesh size. This is actually not minimum, maximum mesh size is this. But this is mentioned in the standard. So you have to maintain this. So beyond that, you can go any number, but if it's a class 1, then even you can go for 3 by 3, no problem. You can go for 4 by 4, no problem. You can even go for 4 by 4.5 even. That's not even a problem, because your mesh size will only matter. That actually talks about an area. That's a collection area. With lightning protection, we are in air termination, we are concerned about that collection area. So that's the concept. So you can use this for flat or even sloping roof. So you can hear this is sloping roof and this is a flat roof. All right, so hope you got that understanding. And natural components also can be used. This is from one of sites. and you can have these bonding conductors using the same metal roof as the air termination, but with this bonding. But this bonding shall be properly done. The selection shall be properly done as well. And there are other concerns to be considered when you are using these natural components. And with the you can have these metallic pipes on roof, but shall make sure with the where it's going and what sort of fluid is it conveying. Likewise, when you're using other tanks and all, you have to use these are these exhaust fans, vents. So if you're using them, then you have to have some sort of other arrangements. So there are natural components you can use. And down conductors, you might have seen these. These are the down conductors on the surfaces, and you have test link. We call this test link, and this is now going to the beyond this. Now this is going to the earth termination, and this is towards the air termination. All right. So this is a test link. So we can separate the link. We can remove the link and keep it open, and you can separate test this earth termination or whatever maintenance work you can do. Yeah, so these are the types of down conductors. So this is metallic strips. This is a metal strip. For instance, this is like 25 millimeter by 3 millimeter. You better write this down, because when you do a design, you might have to come up with a bill of materials, a list of materials. So this is typically 25 by 3, or you can go for higher sizes. So this will depend on your down conductor requirement according to class and number of down conductors. So I will show you number of down conductors in the next slide. This is from a steel column. You might have seen there are certain structures having I channels, right? There are I profiles, I sections. So these are being used for columns. So you can use these same columns, but with proper bonding at air termination and also at termination. You can use this as down conductors itself, but still you have to be aware of what sort of services you are connecting your electrical and electronic earthing to the structures, and if you're mounting them, and also you have to be care of touch potentials. So it's a wide area, yet with the lightning protection you have to consider them. And when you are designing down conductors according to the class of lightning protection system, there are distances you have to maintain in between the down conductors. Okay, and also this is along peripheral length. So I'll show you quickly. So if you have a premise like this, okay, so this will be important for your assignments. So let's say this, we are only considering now about the down conductor system, not the air termination system. Okay, now we are considering down conductors only. Okay, so let's say this is a building. Now we had our air termination over here. So we connected them. Okay, now the part is how we're gonna make this down, this charges down. That's all. So this is a layout of the rope, let's say. And if you're gonna have down conductors like this, so likewise you can. Okay, there are concerns when you cannot just make them down wherever you want. So the distance which I mentioned is this one. Okay, so when you go along the class 1 to class 4, your distance increases. That means you can have more separation apart down conductors. That means you can have lesser number of down conductors continuing along the peripheral. Let's say your total peripheral length is 100 meters, and your gap is, your span is like 20 meters, say. Okay, so you have these 5 number of sections. These gaps, 5 number of gaps. That means how much? Okay, let's say if you have 5 number, you can consider where to locate them. These 5 number of gaps. 1, 2, 3, 4, 5. Okay, but then if it's like 5, you can have over here 2, 3, 4, 5. Likewise, what you have to maintain is to make sure that the distance between these two are not beyond this value. That will depend on the protection class. All right, so these locations will actually depend on your access doors, windows, because you cannot have them across the windows, and you have to make sure about when you down them, you have to make sure that how the function of that ground area, if the people will be there around, there's a potential of always touching it, likewise, because there's a touch potential hazard always there. So you have to keep them in mind as well. Okay, so I believe you got some understanding. This is actually like simple mathematics, and you have to do some geometrical works. Okay. And when you are lying down conductors, you have certain limitations, and looping is not allowed. These are the loops. So like when you have parapet walls, in the, let's say like in a balcony, so when you have these loops, so you have to consider about these distances. Okay, these are given. So if you have if this is D, this separation is D, then the maximum loop length is 8D. So it focuses on this loop actually, because when you are conducting a current from here over to here downwards, so there are chances of spark balls as well. So these were evident by even our consultants in certain day-to-day life applications. So these are possible. So these could provoke to other problems, loops. All right, so these are not permissible. And also if there's overhangs and cantilevered sections where people are residing underneath, if the people are walking, so if you're having like this, so there are possible flashing or thunderbolts, miniature thunderbolts occurring between these, because these are at different voltage and ionization levels. So if it's gonna have these loops or these closer parts, so there's a potential of ionization in these areas. So what you have similarly seen with, I think like Tintin, you might have seen these are arc balls are going around there. So those were visible actually, certain people, even our consultant as well. So this happened, these arc balls can jump from over here likewise. So these are potential with the ionization of this, because it will be a total not electrical actually, lightning physics phenomenon happening over here. Okay, the turbulent electrical field applying, there are certain incidences taking over. So there are issues happening around with these down conductor systems. And earth termination system is the other part. So when you are having a termination system, it clearly says that it shall be less than 10 ohms. Earth electrode resistance shall be less than 10 ohms. So it's given. Okay. So unlike, you have earth electrode resistance in low voltage systems, this is mentioning a value. So Dinonte, can you name another student from the batch? So I have to raise a question.
Okay. Patirana. He left. Rajakaruna.
So Patirana is absent.
Patirana is there, but he left. Okay.
Yeah. So he's absent. Okay.
Rajakaruna, DIM.
No response means no absent.
Okay. Okay, then.
Hello, excuse me.
Yeah. Patirana is
Madam, my connection is not stable.
Yeah. Okay. Can you hear me?
Hello?
Yeah. Can you hear me? We can hear you.
Oh, hello, yes.
Yeah. Okay. Okay. Have you done electrical installation designs? Low voltage.
Simply lightning design.
No. I mean, according to BS 7671.
No.
Somebody from, yeah.
Hello?
Hello. Hi. Hello.
Yes, sir.
Yeah. So when you're designing low voltage systems, low voltage electrical systems, less than 1000 volts. So what's the earth electrode resistance you shall maintain? Anyone who answers this question will be rewarded with 5 marks, right, Dinwantri? Any answer, right or wrong, I don't care. I just need your presence, that's all. Because as engineers, you should speak up, especially during these times, you should speak up. There's some answer, anything. With a solid foundation in your justification. Somebody from the batch, can you tell earth electrode resistance as per for the low voltage electrical installation? Time is ticking.
There are not any mentioned value for electrode resistance.
You are from the same batch?
Yes, sir.
Okay. So why you're saying that?
So in normal insulation systems, if the loop resistance is most important than electrode resistance.
Okay. So where you learned that?
Industrial.
Okay, great. So that's really great to hear, because there's no particular electrode resistance is mentioned in BS 7671. It mentions about the loop resistance. So this is where you get that requirement of achieving earth electrode resistance of 10 ohms. So it took long time to discuss this point, because nobody, until the last moment, nobody answered. So earth termination system shall be less than 10 ohms, and there are 2 types of earth terminations you can come up with, either as individual electrodes to individual down conductor, like here. All right. Or you can have a interconnected system like this. All right. So it's a ring system interconnected like this. So the requirements are as given there, and selection of materials, as I mentioned. Air termination and down conductors, there are given materials. The cross-section areas are there, cross-section areas. So if you take like 25 by 3 metal tape, okay, so it's 75 millimeters squared. So you can see if you are considering copper, if it's a solid tape, so your requirement is 50 millimeters squared, but now you have 75, then that's good. And the comment is given as the thickness shall be 2 millimeter minimum, and it's 3 millimeter we have over here. So it's also satisfying. Okay, so you can see as per the requirements, the materials are in the market and you can use anything. And even for the other table will show you other materials. No. There's another table with other materials as well. So you can use other steels with given cross-section areas. All right, so according to different material, there are different requirements and diameter thicknesses are given there. So when you are choosing materials, you better stick to this table. And for earth termination, you can use materials, and there are different constructions: stranded, solid ground, pipe likewise. So no time to actually go through each and everything, because I'm pretty sure that what I say will only transmit to you like 25 to 30%. Okay, I'm pretty sure with that. So to minimize the losses, I will not tell anything much. While you do any assignment or any design, you better refer and do that. And you can either have earth rods or a conductor, means even have a tape or a rope underneath the ground, and you can even have an earth plate. All right, okay. And so this is what I mentioned. So when you are choosing the materials, you have to be careful about this corrosion properties. See, so during an inspection, we found this being corroded. So there will be no use of the lighting protection system if these connections are gone. Okay, so you have to make sure of the corrosions. So internal LPS is what I mentioned about these surge protective devices to mitigate overvoltage instances where transient overvoltages are present, because with surges you might face malfunctions or even malfunction of equipment or even destruction of equipment. Now, like past couple of days, we've been hearing lots of about failures in variable frequency devices and generator controller modules and even lift controller modules. So likewise, there are plenty of sensitive equipment and even CCTV systems. Those are really popular, and even sometimes we have even seen some certain distribution boards have blasted away and falling pieces all around after a certain surge event. It's not even a lightning strike directly to the structure, but even from the surge it's traveling through the line, it will even destroy an entire panel. So that will even cause life-threatening issues to occupants. So this is not something simple. So you have to keep that in mind. All right, so these are the switching surges. You can see the lightning, the magnitude, and during operations, switching operations, when you are using those switching devices, MOSFETs and all for your drives, switching drives and inverters, you get frequently these surges. So to avoid that, you need to have surge arresters. So these are the classification of the same source of lightning strike and all we discussed earlier. And the zoning, lightning protection zoning is also important. The most exterior one is the lightning protection zone 0. And likewise, when you're going internally into the building, you are going up to lightning protection zone 2, right? So when you have classification further, then you have 0A, 0B, likewise, according to the boundary of the zone. Yeah, so the requirement of fulfilling the surge protection device selection is also given in what we discussed is 7671, BS7671, 8th edition. The all the parameters are given there. So correct connection is really important. Having SPD is not the thing. You have to connect it correctly. So these connections, I believe, for you, it's not the time to discuss further, because if you haven't even seen a surge protected device in your real life, or if you haven't installed it, I believe further going through the details will be futile. But if you have seen them, you can have better understanding while you refer the standard. Yeah, because without sometimes seeing even equipment and items, your learning is not effective. At least try to search through the Google and let yourself see them and cross-refer the standard, and it's giving all the values required to parameters, like you have this UC value, I impulse value, right, and I max values, right, and UC values. These are continuous operating voltages, and these voltage residual voltage applying across, and the impulse value for when you say like class 1 SPDs, and for IMAX for like class 2 and 3 SPDs. So you have to select them according to the applications, right? So UC values usually 1.1 times your phase voltage if you are individually having for SPDs for phases. So this 10% is your system maximum that could go rise until, okay? And UP is to be decided depending on your equipment which are connected. So if you have like quite sensitive equipment, then you have to have like 1.5, less than 1.5 kilovolts UP values. But when you have higher withstand voltages, you can have increased this, and throughout the installation also you have SPDs, not only at the particular connection. So you can see when you get a lightning strike, if it's conducting downwards, all right, this is the external LPS, not the internal, external LPS. This is a separate one, but now you have electrical installation as well. So if you're having these together, then you will have a problem, but it's eliminatable. So there are solutions and measures to practice. So if you're having it, then you better have it afar, at least like 20 meters, let's say, afar. Depending on all your characteristics, you can decide this. And if you're having this electrical installation, you place your SPDs over here, and you have your equipment throughout your installation. But the earth termination is also important there, because that's what I said. If you are connecting it incorrectly, then it will pose a lot of problems, because sometimes people are connecting this earth at a different end. So it is causing unnecessary problems to the installation. So these are coming up with all the earthing and bonding concepts. So it's beyond LPS, it's beyond the basics of BS7671, but you have to just keep in mind that these earthing and bonding should also be considered, okay? So when you are connecting SPDs, you can have SPDs right over here, and even at your distribution boards, like over here, and even like over here, because these surges are traveling through the lines, right? These surges are traveling through the lines, and their waveforms are changing also. Here you have different waveform with high energy, and here slightly low energy, and here quite low energy. Okay, so keep that in mind. I believe there's a slide explaining that. And there are CT connection types as well, CT1, CT2 connection types. If you have time, you go through these, you can simply search on internet and you can refer them if you have time, and if you can figure out everything else. Otherwise, I know that this is confusing bit, but if you're going to practice it, you have to have a proper understanding. Otherwise, you will face unnecessary problems. Okay. For the different class types, there are SPD classes. Say class 1, type 1, type 2, type 3. Okay, class or type. So this is what I said. This is the waveform which is coming initially 350, 10, 820, and 820 residual surges. 1055 is a high energy waveform. Okay, so this is actually, these SPDs are to comply with different tests. So the SPDs are satisfying test, and that's where they have been used for different applications. So as I told you, the power is coming from here to here. Okay, you can see the power line is coming here and it's connected to multiple installations, and we are considering our installation, and it's coming to the, let's say, energy meter with the breaker, and have a let's say there's an external DBO here, and it's distributed into our internal areas. So according to the zone categorization, is coming in and inner, and you can see the waveform is 355, 10 355. It's a huge amount of, because this is 10 is here and 355 is where you have this 50% drop of the waveform. You can understand the how huge amount of energy coming from this surge, and quite and attenuating all along our path. The energy is lessening. So there you can install these SPDs according to these waveform characteristics. So that's the concept, and selection of SPDs like that. If you have a lightning rod, then there's a high chance of direct lightning strokes coming into there. Then you have to consider this high impulse value. Otherwise, the maximum follow-up currents to be considered only. So if you have a lightning arrestor, then you shall definitely go with the type 1 plus other SPDs all along your installation. So that's the basic concept. Because designing all these have different approaches, and those are like substreams of this LPS design. And the most important thing is, as although you are students, you shall be make sure that when you are installing SPDs, the cable length shall be limited. Otherwise, they will create unnecessary problems. So overall, it is mentioned that if this is the SPD, okay, this is SPD. So you have cables over here and you have cables over here. So the total length of cable shall be better less than half a meter. That means 50 centimeters, but not necessarily more than. This is better. Not better, actually. This is the yeah, this is better. This is better, but it's mandatory. That means it's essential to have it less than 1 meter. All right, so this norm shall be kept in your mind. This is also mentioned in BA 7671 as well. All right, and looping of your cables will also create problems with the power cables, because the higher the loop volumes, the higher the electromagnetic effects that will create. Okay, the electromagnetic compatibility of this equipment will be decided upon these loops. So when you are installing cables also, just make sure that, because this data cable, if you have a screen, then there could be circulation currents going all around, and there's a loop. So if you have a loop, then there could be problems occurring to your appliances. If it's electrical DB, if you have loops, and internal components can have problems during switching moments. During switching moments, all these quick inductions will happen. Then your your electromagnetic forces will increase, and your induced voltages will increase. Likewise, there could be damages to your equipment. These are the ratings I mentioned: UP, UC, IN, and IE pulse values. Yeah. Okay. So when you are designing, the workshop is for designing. So first you have to get the client requirements, right? You have to get the client requirements, and you have to pay a site visit, right? You have to check around what's the requirement and see, and then you come up with the design. Okay. You prepare drawings and you prepare a report, And based on the design, you will come up with a BOQ, right? Bill of quantities. That means the list of items are used with the quantities, how many much of meters, the test links, how many numbers of test links. Likewise, BOQ examples are there. You can refer always. And engine's estimate is the cost estimate for your BOQ. Yeah, okay. And the specifications are explaining the items. Like when you are saying that copper tape, then you have to mention 25 by 3 and what's the construction of the tape copper material. Yeah, so there are impurities in the copper, so you have to mention what are the specifications clearly. Yeah, so these industrial construction, because since we are focusing on designing, there are different materials you can refer, the different types of arresters, okay, different type of air terminations, and also for the down conductors, you have this sort of down conductors. These exclude actually those natural components. Otherwise, you have those rebars and all, and you have earth electrodes as rods with mesh tapes or even plates, right? And also these connection accessories, you have to connect them with using either clamps, clips, or exothermic joints. And these are the test links I mentioned for disconnecting the down conductor from earth termination. Yeah, okay, so that's the approach to designs which we have discussed so far. So you can understand there are a lot more to discuss even beyond that, but since we have exceeded our time limit as well, because I needed to give you at least 50%, of the knowledge. Okay, so there are a lot more, and this is not actually linear knowledge gaining. When you have to gain a lot more knowledge, it will further increase the required learning experience and likewise. So out of the knowledge, I believe I have transferred at least 50% of the knowledge, and it's over to you, the moderator. Thank you.
Thank you very much, sir. So we have come to the end of this unique webinar that explores the essence of lightning protection design. So I would like to express my heartfelt gratitude for honorable invitation today and sharing your valuable knowledge with us. So please accept this token of appreciation. Thank you very much.
Thank you very much for inviting me over to this event, and thank you for the great support provided by the moderator and Dinwanti as well. And I wish the interaction of the audience was much better, and definitely with the increased time span, the number decreases. That's the usual formula and the nature. So I believe the people around here have gained some sort of knowledge, and I'm willing to share further knowledge in future sessions as well. Thank you.
Sure, sir. Thank you very much. So next, I would like to invite Secretary of IEEE Student Branch of University of Ruhuna, Ms. Amithi, to deliver the vote of thanks.
Hope I am audible.
Yes, you are.
Thank you. And a very good everyone. It has been such an honor to be a part of this wonderful event. So on behalf of the IEEE, I would like to extend my heartfelt gratitude to our guest speaker, Engineer Laksith Siirisena, the electrical consultant in Amithi Power Consultations Private Limited. Thank you very much, sir. Sincere thanks to the former chair of WIE, Lecturer Dinwanti Miller, for giving us this wonderful opportunity to organize such a valuable event. And a wide round of applause and thanks to the IEEE University of Ruhuna and the Power Circle of EIES for the organization. Finally, I would like to thank all the participants helping us to make this event a grand success. Thank you very much and have a good day.
Thank you very much. So at last but not least, thank you everyone who have participated today. Let's meet from another worthwhile webinar. Have a nice day.